I am Dr. Binu. In Digital Signal Processing subject, the fifth unit is DSP applications. It consists of multi-rate signal processing, decimation interpolation, sampling rate conversion by a rational factor, adaptive filters, applications of adaptive filters to equalization, DSP architectures, fixed and floating point architecture principles. The first topic is multi-rate signal processing. Multi-rate signal processing is a technique in DSP where a signal is processed at a multiple sampling rates instead of single constant sampling rate. For example, if your audio is recorded at 48 kHz, may need to be converted 44.1 kHz for CDs. Video and communication systems often request different sampling frequencies. What is the need for multi-rate signal processing? Multi-rate processing is important for several reasons. First one is sample rate conversion. Different systems use different sampling rates, so conversion is necessary. Second one is reduced computational complexity. Processing signals at lower sampling rates reduces the number of calculations required. Third one is efficient filter design. Multi-rate techniques allow efficient implementation of digital filters. Fourth one, better system performance. It improves speed and reduces hardware requirement. What are the basic operations in multi-rate signal processing? There are three operations. One is decimation. It is also called as downsampling. Second one is interpolation. Another name is upsampling, sampling rate conversion by rational factor. What is meant by decimation? It is a downsampling method. Decimation is the process of reducing the sampling rate of a signal. If the original sampling rate is reduced by a factor m, the process is called decimation by m. If the input signal is sampled at 20 kHz, we decimate by m is equal to 2, the new sampling rate becomes 20 kHz by 2 is equal to 10 kHz. Mathematical representation. If the input signal is x of n, the output signal after decimation is y of n is equal to x of n m. M is the decimation factor. While using decimation, we are using anti-aliasing low-pass filter before the downsampling. The different waves formed for decimation is represented. Need for anti-aliasing filter. Before downsampling, a low-pass filter is used to remove the high-frequency components. Without filtering, aliasing occurs, which causes distortion. What are the applications of decimation? Decimation is applied in speech processing, digital communication receivers, and audio compression systems. It is meant by interpolation. It is also called as upsampling. It is a process of increasing the sampling rate by a signal. If the sampling rate is increased by a factor L, it is called as interpolation by L. In interpolation, after upsampler, we are using anti-imaging low-pass filter. Working principle. During upsamples, zero samples are inserted between original samples. A low-pass filter smooths the signal and removes unwanted frequency components. The original samples x of n is equal to 2, 4, 6 means after interpolation by L is equal to 2 means y of n becomes 2, 0, 4, 0, 6, 0. Then filtering smooths the signal. The upsampling and the corresponding waveforms are represented in the slide. What are the applications of upsampling? Audio reconstruction, digital to analog converters, and image scaling. What is meant by sample rate conversion? Sometimes the sampling rate must be changed by a fractional factor L by M. This process is called as rational sampling rate conversion. That is, sampling rate conversion is nothing but the combination of interpolation and decimation operation. The sampling rate conversion process and its output is represented in this slide. Advantages of multi-rate signal processing, which reduces computational complexity, improves processing efficiency, It allows flexible sampling rate conversion, reduces hardware cost, enables efficient filter implementation. Some more applications are in digital communication. It is used in channel coding and modulation system, in audio processing, MP3 compression and speech coding, image and video processing, image scaling and video compression, biomedical signal processing, ECG analysis, and EEG signal processing. In multi-rate signal processing is a branch of DSP that deals with the processing signals at more than one sampling rate within the same system. It is a technique of processing digital signals using multiple sample rates to improve efficiency and flexibility.